All right, so hello. So we are going to continue talking about our Unit 4 with talking about how we're going to balance equations. And so up to this point, we've talked about the law of conservation of mass, which told us that, all right, whatever mass we start with at the beginning has to be the mass we finish with. And so when we talked about that, we saw some examples of some equations where they were not balanced. Okay, so they were not in a way that satisfied the law of conservation of mass. And so what we want to do is make sure that we follow that law, and how we do that is by balancing these equations. So that keeps us from having situations where we have like hydrogen or some atom that just disappears. Okay? Because we know that that can't happen because whatever we start with has to be accounted for somehow at the end. And so just like you saw in the ed puzzle yesterday, what we're going to do to balance these equations is add coefficients. Okay? And so what a coefficient is a number that you probably have heard in math class that you put before a variable. And so what it tells you is that whatever is after it is multiplied by that coefficient. So an example would be like 3x, the coefficient there is 3. All right? And so you multiply that x by 3. And so if we look at an equation, okay, so here's an equation where we have water and it goes to hydrogen and oxygen gas, right? And so if we look at this right now, again, to see if it's balanced or not, we want to look to see, okay, are there the same number of atoms of each element on each side of the arrow? So if we look at the reactant side, which is the left side of the arrow, we only see that there's 2 hydrogens, okay, and there's 1 oxygen. And if we look at the right side, we have 2 hydrogens and 2 oxygens. So right now we can tell that, okay, this isn't balanced because, well, where did that extra oxygen come from? Right? We don't know right now. All right. And so what we want to do is we want to balance this by adding coefficients. And so we can only add them before the compounds or elements. So what that means is, again, this was gone over a little bit in the ed puzzle, but we can't change these subscripts, okay? So the little small numbers are here to stay, all right? We can't change those, but we can add coefficients before our compounds or elements, all right? So that's what that means. And so those 3 locations where right now we could add a coefficient would be before the water, okay? Before the H2 or before the O2, all right? So it's really important that when we're balancing that we never change our subscripts, and we only change our coefficients. And so there's a little bit of a checklist when you go through and you want to balance these chemical equations, because it turns out to be a little bit like a puzzle, okay? And so the first thing we want to do is, when we're looking at balancing them, you don't want to try and like balance the whole thing at once, all right? So you want to try and balance the different types of atoms one at a time. And so what you want to do is you're like, okay, well, there's a bunch of different atoms here. Which ones do I choose? Well, the ones that you want to start with are the ones that only appear once on each side of the equation. And so as we go through and do some examples, this will make more sense about what that means. But you want to look to see, okay, is there things that only appear one time on each side of the arrow? All right. And so again, as we go through and we do these, this is going to make more sense. But you may have remembered a couple weeks ago, I talked about something called polyatomic ions. All right? So polyatomic ions are things that have multiple atoms, but they act like ions. All right? And so when we see those in equations, it can be a little bit tricky to balance them. And so you want to be able to look and see, okay, well, where are my polyatomic ions? And so again, as we go through and do this, this will make more sense, but there's a couple ways to know that, okay? One is that it's listed on the reference sheet that you have. Also, a lot of times these polyatomic ions will be in parentheses. Okay? So again, as we go on, we'll talk more about that. And the last step is, if you have hydrogens and oxygens in your equation, okay, and there's other elements present, you want to start with the other elements. And the reason why is because hydrogen and oxygen kind of show up a lot. And so a lot of times if you try and start with them, you have to go back and end up changing whatever you started with. All right, so we want to try and save those for the end if we have other elements that are present. All right. And so the best way to see how to do this is just by doing examples. Okay, so this is that equation that we had a couple slides ago where we saw that right now it's not balanced. Okay, and so what we want to do to try and balance this is we're going to set up this little chart here. Okay, so this little table. And so what this shows us is, okay, what elements do we have? So in this case, we only have hydrogen and oxygen. And then there's going to be a blank side on the left and a blank side on the right. And what this is going to allow us to do is keep track of how many of each element we have on the left side of the equation, so the left side of the arrow, and how many we have on the right side of the arrow. Because at the end, if those numbers don't match, we know that we haven't balanced it correctly. And so what we want to do is if we go and we write out our equation and we draw out that chart, you want to see, okay, how many of each element do I have to start with? All right, so we look, I'm like, okay, we look at the left side of the equation. Right now, again, we can't change our subscripts, so I have 2 hydrogens and I have just 1 oxygen. Then I look at the right side of the equation and I have 2 hydrogens and I have 2 oxygens. And so right now I can see that, okay, this is not balanced, right? Because right now I have 1 oxygen on the left and 2 oxygens on the right. So again, to fix that, the only thing I can do is put coefficients in one of these 3 locations on the equation. All right. And so again, you don't want to try and balance the whole thing at once. So you want to look and be like, okay, well, what is unbalanced? Well, oxygen is unbalanced right now. And so I look and I'm like, well, okay, I know I need to get a 2 over here to balance the oxygen over on the right side of the equation. So again, I can put a coefficient here. So let's just start by putting a 2 there. Because then what that does is that multiplies this whole thing by 2. So you can write in, okay, I times this by 2, okay, and so now I have 2 oxygens. What you want to remember though is that again, this 2 goes to everything. So this 2 goes to the hydrogen and it also goes to the oxygen. So we also multiplied the hydrogen by 2, so now we have 4 hydrogens. So now we're like, okay, cool, our oxygen is balanced, but now our hydrogens are not. And so we need to fix that. So we have 4 on the left side and only 2 on the right side. And so to get to 4, if we put a 2 here, that again is like multiplying the whole thing by 2, so we get a 4. And so now we're happy because our 4 and 4 match. And so for the one that we didn't put any coefficient on, okay, you can either just leave it blank or you can put a 1 here. It doesn't matter, either way. All right. And so this would be like your final answer. So how you would write this would just be, okay, 2 H2O, and then our arrow goes to 2 H2 plus O2. So again, you can either write a 1 here, you can just leave it blank. And so a common question is, okay, well, what does this mean? All right, so what is the difference between, say, this 2 and this 2 right here? So this 2 is like a quantity of different molecules. So if we were to draw this out, we would have 2 water molecules. Okay, so that's what this 2 means, is that there's 2 of them. Okay, so on the same respect, this 2 means that there's 2 hydrogen molecules that each have 2 hydrogens. So there's like 1 molecule here and a second molecule here. So that's what this 2 means. The fact that there is just a 1 here means that there's just 1 oxygen molecule. This subscript 2 just says that that oxygen molecule is made up of 2 oxygen atoms. Okay, so that's what the difference between these numbers are. So again, if you want to look and say, okay, is mass conserved? Well, you can go back and you can count up the atoms and be like, okay, well, on this side I have 1, 2, 3, 4 hydrogens. And on this side I have 1, 2, 3, 4 hydrogens. And then I can be like, okay, I have 2 oxygens here and 2 oxygens here. So again, that's not something that you have to do, but if you're confused and you want to make sure that you get it right, you can always draw them out using those structural formulas that we talked about. All right. So let's do some other examples. So this is one where we have hydrogen and fluorine and they're reacting together. And so here we've included our state symbol, so that doesn't affect how we balance at all. Okay, it's just some extra information. But again, what we want to start with is say, okay, well, how many of each atom do we have? So if we look at the left side of the arrow, we have 2 hydrogens and we have 2 fluorines. If we look on the right side of the arrow, well, we only have 1 of each. All right, so right now we can tell that we are not balanced. So again, how do we fix that? Well, we can put a coefficient at any of these locations. And so you can probably see that, okay, well, we want to get to 2 over here. So we want to somehow multiply these each by 2. Well, we can do that easily by just putting a 2 here, right? Because then we have 2 hydrogens and we have 2 fluorines. And so now we're all balanced, so we're all set. Again, you can either put a 1 here or you can just leave it blank. All right, so either way. And again, what this 2 tells us is that when we have this equation, we end up with 2 different molecules of HF, so 2 separate molecules. So you could draw it out like this, all right? So there would be 2 of them as opposed to just 1, all right? So let's do a harder one, okay? And so this is that situation that I told you about where, okay, a polyatomic ion is in here. And there's 2 ways to know that there's a polyatomic ion. One is that you see that there is these parentheses here, okay? So there's that. The other thing is that if you want to, you can go to your Google Classroom page, okay? And if you look on this side here, there's a Chemistry Resources tab, and this is where that reference sheet is located, all right? And so you could even see that, all right, here are our polyatomic ions. There is the NO3. So that's probably more work. So it might be easier for you just to notice, okay, that there are some parentheses here. And so the reason why this is important is kind of a shortcut, a faster way to do it is instead of making a table with both nitrogen and oxygen, so something like this, so you can do this, all right? There's nothing wrong with this, okay? But since those nitrogen and oxygens are in this polyatomic ion, they're kind of like a pair, and so it's just a little bit easier because it's one less thing that you have to keep track of. Okay, so instead of writing the nitrogen and oxygen separately, we'll just write the whole thing as a package. So everything that's in those parentheses, we'll just write as NO3. All right. So everything else we see is just single, so that's where we got like the HE, the BA, and the S from. But here we can see that this is a little bit more difficult than the ones we've seen so far. But the steps remain the same. So we want to look at the left side of the equation and see, okay, well, how many silvers do we have? So silver is Ag. Well, we have 1 of them on the left. Okay. And then again, we're going to treat this NO3 as like a whole thing. Okay. So the reason why there's not parentheses here is that there's only 1 of them. Okay. So since we don't see parentheses there, there's just 1 NO3. If you want to treat it separately, you can, okay? So you could do that. If that would be like using this table over here. If you want to treat that separately, you would still have 1 silver, but you would have 1 nitrogen and then 3 oxygens. So again, either way, it doesn't matter, okay? You'll end up with the same answer at the end. But if we go back to this black table here, we look, and again, on the left side of the arrow, we have 1 barium and 1 sulfur. So then we want to move to the right side of the arrow and see, okay, well, we still only have one barium, all right? And then this is where it can get a little tricky because this 2 here goes to the entire parentheses. And so what that means is that there is 2 NO3s. Okay. So if you want to do it where you do it separately, this is the important thing to keep in mind. Okay. This 2 again goes to each location. And so you would have to multiply. So you would get 2 nitrogens and 6 oxygens. So again, if that didn't really make much sense or you think that that's just going to confuse you, I would treat it as an entire package instead of doing this right side. But again, it doesn't matter, whatever works best for you. So then if we move back over here, we've taken care of this one. So we want to move to this Ag2S. So we have 2 silvers and we have 1 sulfur. So again, same thing, even though this just looks different, we want to fill in our coefficients. So these are our 4 locations where we can put coefficients. And so we look right here and we're like, okay, well, we're good with barium and sulfur, but well, on here on the left side, we only have 1 silver and 1 nitrate. Okay, that's what the name of this NO3 is. And so an easy way to fix that would be to put a 2 right here, right? Because then we would multiply these each by 2. And so that would give us 2 and 2. And so then you can actually see that, well, this looked pretty complicated, but we're now actually balanced. All we had to do was add a 2 here. So again, you can either leave these blank or you can put in 1s. It doesn't matter. All right, but if you use this one over here, you saw the same thing, okay? So you would see that there's a 2 and a 1 and a 1, right? So this whole thing would be the same. It's just when you put this 2 here, you would like multiply each individual element by it, okay? So you would multiply this silver by 2, nitrogen by 2, and oxygen by 2. So again, you're going to get the same answer, okay? Because you'll see that if you do that, each of our numbers match up, okay? It's just it kind of takes an extra step. All right, so that is that one. So let's go to one that is probably the hardest one. So there's no polyatomic ions in this, but this one is a little bit more difficult because you're going to have to add more than 1 coefficient. So again, if we start by just looking and saying, okay, well, how many of each element do we have? On the left side, we have 3 carbons, okay? We have 8 hydrogens, and we have 2 oxygens. And we look on the right side, and we're like, okay, we have 1 carbon, we have 2 oxygens, excuse me. We do not have 2 oxygens. This is where you want to make sure, okay? We look here, and we actually have 3 oxygens because we have 2 right here. But if we look at our second product, okay, we have a water here, and that water has an oxygen as well. So there's 2 oxygens here and there's 1 oxygen here. So that is actually 3 oxygens total. All right, but then we look at hydrogen and we still have 2. Okay, so right now we can see that, well, we're not balanced at all. Okay, none of our elements match up. And so we would still treat this the same, okay? We have 4 places where we can put coefficients, right? Because we can't change the subscripts, but we can put in coefficients. And so this is where, if we think back to that checklist I gave you, there was that reminder to only look and see, okay, what only occurs once on each side of the equation. And so what I meant by that is this carbon here, okay, is only in one place on each side of the equation, okay? So there's a carbon here and there's a carbon here. But if you look at something like oxygen, okay, the oxygen occurs here, but it occurs in 2 places on the right side. So that's what I meant by, okay, only start with things that occur on one side of the equation, or once on each side of the equation, okay? So if you look here, we're like, okay, well, we want to somehow balance this carbon. And so if we say, okay, I want to get this to 3, if we multiply that by a 3, in order to do that, okay, we would have to put a coefficient 3 here. All right. So I'll get rid of these arrows just so they don't confuse people. And so all I've done right now is I've put a 3 in front of this CO2 because that would give me 3 carbons. Because again, this 3 would multiply each of these elements. And so again, if I do that, I look here and I'm like, okay, well, I have to multiply that oxygen by 3 as well. So that would get me 6 oxygens. Okay, so there'd be 6 oxygens on the left-hand side, and there'd be 1 oxygen here. So now I would actually have 7 oxygens. So there's no longer 3 here, there's now 7. And so again, I still need to balance things. Okay, so I look and I'm like, okay, how do I balance this hydrogen? Well, I want to get to 8. Okay, so if I multiply this by 4, I get an 8 here. Okay, so in order to do that, in order to multiply that by 4, I would have to add a 4 as a coefficient here. And so if I do that, what that does is it multiplies the hydrogen by 4 and the oxygen by 4. And so now, the reason why I did this one down here a little bit differently is because now I don't have 7 anymore, okay? I have 3 times 2 is 6, okay? And I have 4 times 1 is 4. So I have 10 oxygens, right? Because this 4 multiplied the hydrogen and also multiplied the oxygen by 4. And so now I have 10 on the right-hand side, so I want to be like, okay, how do I get 10 over here? Well, I would need to multiply that 2 by a 5, right? Because that's how I'd get to 10. So in order to do that, I would have to put a 5 as a coefficient here. And then if I look, I'm all set because I have 3 and 3 here, okay? I have 8 and 8 here, and 10 and 10 here. So these would be like the most difficult levels of ones that you would have to do. So if you were to say write this out as a final equation, again, you can either put a 1 here or leave it blank, you would write C3H8, okay, plus 5O2 goes to 3 CO2 plus 4 H2O. And so this would be like the final answer that you would write. And so you can see that's a lot different than what we started with. Okay? So again, this would be the hardest level. So if everything made sense up to this point, you're still in a good place. Okay, so these ones will come as we practice more of them. But your homework for tonight is a Google form just to get started with this, trying this out. Okay, and so again, you can take it as many times as you want. So if you get a bad score, just keep trying. Okay, and again, don't be too worried if you're a little confused on this. This is pretty tricky. Okay, so we're gonna spend a lot of time practicing this.